Okay, so last but not least in terms of the two techniques, uh, condensed structural formulas. So before we would draw lots of lines and stuff and show all the structure, didn't label any of the elements. I believe the roots to this technique really have to do with the fact that a lot of times we had to represent stuff in uh, typed paperwork using a typewriter back in the old days. Now you can have a computer draw whatever you want and throw it into a Word document and you're good. But you didn't have that on a typewriter. You didn't have that typeset. And so you'd have another way of representing molecules that basically used almost all letters. And we've actually cheated it and made it easier since then. So there's kind of a newer flavor to it. So I'll show both the easier new way and how they did it back in the old days, the bad old days. So if we have something like, I'll stick with good old pentane, so 5-carbon chain, and I'm going to draw the Lewis structure for this one last time. You should be familiar with it by now. So lots of carbons with 2 hydrogens in the middle, well, 3 of them, and then each end has a carbon with 3 hydrogens. So this is the example I've used at least twice now. And so the condensed structural formula is we basically write this carbon group by carbon group. And so I go, okay, this carbon has 3 hydrogens, that's a CH3, this carbon has 2, CH2, the next one is a CH2, CH2, CH3. So this is our Lewis, this is our condensed. And what we do is we just write it carbon by carbon, carbon group at a time. And so hopefully you can see how you can do this on a typewriter with some ease. So we write each carbon group. And then what there is. So we're writing this. So what are we implying? Well, we're not showing any bonding structure. So we are implying something about the bonding structure. So we're implying that whatever's after the carbon is bonded to it. And then we're also implying that this carbon is bonded to the next one. So this is like a train car. It must be connected to the next train car, which must be connected to the next train car. This is the payload on this train car. This is the cargo on this one, so on and so forth. We just carry our way through. So we write each carbon group one by one. We just take it piece by piece. We write what each piece is. And then we're implying bonding between these carbon groups. Okay. Now, the line structures were great for showing double bonds and triple bonds. Now, the bad old days, this would be trickier. So if we had something like, carbon double bonded to carbon, we'll keep it simple. Just 2 carbons. So this is known as ethene. Again, you don't have to know any of the names. The condensed formula for this would be CH2, CH2. So how do you know that there's a double bond there? You'd have to look for missing hydrogens. You'd have to be like, I don't see, if this carbon's connected to 2 things here and then there's a connection here that's only 3, so there must be a double bond here. So this is the bad old days. Today, again, because computers can do this stuff, also we've invented the equal sign, which also makes this easy. This is what we do. So condensed formulas used to be a little rougher. We actually take a little time and show more on them, which makes them easier to interpret, but it makes them a little longer to write. Okay, so same deal with triple bonds. Bad old days, you would see like CH or something like that. Now you'd see CH triple bond CH. What about branches, right? So if we have something like, whoops, I'm already writing I'm in condensed formula mode. All right, we go carbon, 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 carbon. All right, so we're gonna have a branch. We'll have a 4-carbon chain with a branch. Okay, so fill out all the hydrogens. Okay, So how do we do this in the bad old days? Well, we go CH3. Okay, we get to this carbon. That's the next one that it's bonded to. That's a CH. And then we would use parentheses to denote a side chain. And then we go, what's the side chain? CH3. That's the end of the side chain. We close it. And then we come back to the main chain. CH2, CH3. So again, this is bad old days. This is mostly in case you look up any online resources and you're like, what are these people doing? Here's today. Today, technology makes it so we can do things a little easier. I just go CH3, and so what it means is today we can always sneak in stuff about the bonding structure a little bit. So we show a bond to connect the side chain, and if it went longer, if it was like CH2, CH3, we would just write that. That's what we would do. So those are kind of the two tricks. We'll stick to the today style of this because that's how all the questions are formatted. But yeah, be aware that if you do look up other resources, you see something like this, that's what it means. All right, so let's put this to practice a little bit. I'm gonna write some Lewis structures. You're gonna give me condensed formulas for those structures. See if you're paying attention. You should know this one if you're listening to me earlier. And then we'll go yeah, I like that. I think that's what I did last time. I gave myself more room to write it this time, so it isn't too bad of a mess. So we'll have a 5-carbon main chain, a couple side chains on it. I'll let you figure out the details. You've seen the line drawing for this before. Can you do the condensed formula? Alright, so I'm just filling in the hydrogens. So as you can see, Lewis structures, right? You're starting to feel a little impatient, taking some time. That's okay. That's why we have the shortcuts. So look at that. Isn't that beautiful? It just takes up so much of the page. It's going to take up so much less over here. And I'll do one more. What else did I do? Yeah, we'll do one double bond practice. So this one will only be 3 carbons. Okay. So we got 1, 2, 3 to practice. Take a crack at them. I'm going to work through them here in a second. And, you know, if I do one and it reminds you of something, you pause it and work through the other ones and then resume. But all right, so we've got double, triple bonds, we've got side chains, we've got everything to practice. All right, so this first one, I got a CH triple bonded to a CH. There you go. Like I said, we're going to do the today version, not the bad old days. So that means I'm actually going to show you the triple bond so you know it's there. You don't have to use any detective work to figure out it's there. So we imply less, we show more. It takes a little longer to write, but as you saw, it wasn't bad. All right, this one. Time to cowboy up. All right. We've got a CH3 to start out. This carbon only has 1 hydrogen, but it has a side chain. That's a CH3. Okay. And then we've got another CH. And we've got a CH2 connected to a CH3. So as you can see with the side chain, we just start writing it out like we would the main chain. When we're done, we come back and we go to the next carbon. We've got another CH. That has a side chain of just a single carbon, CH3. Then we come back. What do we got? CH3 to kind of cap the main chain. So there you go. So we've got a side chain that's longer than 1 carbon. How do we handle it? Well, we just write it like the main chain. We just go carbon by carbon. We show a branching bond here. You could do the parentheses trick if you want to do it the bad old days way. That's fine, but be familiar with this because this will be what you're tested on. Okay, so last one here. What do we got here? We got a carbon with 3 hydrogens, right? So we got a CH3. We got a CH. We got a double bond to a CH112. Okay. that's it. So there's more worksheets to practice this. I highly recommend them. Make sure it clicks, because we are going to build on this in the next video. So everything I've shown, if you're like, oh my god, this is so complicated, we can branch carbons, we can do triple bonds, we can do double bonds. Yeah, that's complicated. I've only shown you 2 elements in these structures, though. There's a whole periodic table full of them, all right? And we're going to talk about that. And we're going to talk about what are called functional groups, and that's what happens when I start folding in other elements. All right? I've actually shown you 2. Double bonds are a functional group, triple bonds are a functional group. There's a few more as well that involve other elements. Okay, so make sure you practice with this, because I'm going to start showing a lot of condensed and line structures in the next video.